Good evening, Internet. I am Matt Buyak, and in this video, we're going to take a look at the 26th problem from the Project Euler problem archive. So this problem asks a question about the reciprocals of natural numbers less than 1,000. It observes that the decimal expansion of any such number must eventually repeat in some kind of cycle. And it asks us to find the denominator of the reciprocal whose expansion has the longest cycle length. So with that in mind, let's get into it. As usual, we'll copy our template directory to make our problem directory. And before we begin, we will need to do a little bit of analysis. So let's open up our analysis file. So let's start by considering the decimal expansion of 1/7. 1/7 is equal to 0.1428, I believe it was 57. Yes, that's correct. And so we're just going to ask the question, how do we determine the digits of this expansion? And so first note that if we multiply this expansion by 10, the integer part corresponds to the first digit. That is, 10 times 1/7 is going to be 1.428571. I should have indicated here that this is continues. This is repeats forever, as does this. And so you'll notice that just by taking the integer part of this, we can get the first digit. So then after subtracting, we'll say after subtracting the integer part, we're left with 0.428571 ... And we can repeat this process to get subsequent digits. We can multiply by 10 again, look at the integer part, that'll give us the next digit, and so on and so on. And so this gives us an algorithm for extracting digits. So we'll say algorithm for extracting digits. First, we're going to multiply by 10. Note the integer part. Subtract the integer part. And repeat steps 1 through 3 as desired. Okay, and so above here we were mostly working with the decimal expansion, but this procedure also works when dealing with the fraction, which is what we're given. Suppose we didn't have this decimal expansion and we wanted to determine the values of these digits. This is the algorithm that we would use, but applying it to the fraction instead. And so let's just make a little table here. So we're going to say fraction. Then we'll say multiply by 10, and then we'll just note the digit. Okay, so we're starting off with 1/7, and then we're going to multiply by 10, so we get 10/7. We note the integer part, which is going to be, you'll notice that 10/7 is equal to 7/7 plus 3/7, or 1 plus 3/7. And so the digit will be 1, and the remainder is 3, and so the new fraction is 3/7. Okay, so we'll multiply that by 10 and get 30/7. You'll note that 7 times 4 is 28, which is just less than 30. And so our digit will be 4. The remainder is 2, so we have 2/7. Multiply by 10, 20/7. And so the digit will be 2, and we'll have a remainder of 6, so 6/7. Multiply by 10, 60/7. That will be, or you notice that 60 is just greater than 56. That is 8 times 7, and so we'll have the digit 8. That's a remainder of 4, so we have 4/7. Then 40/7. You'll notice 35 is just less than 40, and so that's a digit 5. And so we'll have a remainder of 5, so 5/7. 50/7. 49 is just less than 50, and so we have the digit 7 and a remainder of 1. Okay, and you'll notice, note we're back where we started. Okay, so you can see over here we have indeed produced the same string of digits as was listed on the Project Euler website here, and that we did indeed repeat. We got back to 1/7 as our fraction, and so if we continue the process, we're just going to get that same string of digits over and over again. And so I think this probably makes it clear enough, the process for determining the digits from the reciprocal. And so I think now we can get into writing some code. So let's open up our main.cpp. Okay. So we'll need a way of keeping track of, before we start writing code, let me just note that the only possible values for the numerator are values less than 7. Our fraction is always going to be less than 1. And so we only have to consider numerators that are less than the denominator. And so you may recall that we are going to be considering denominators up to 999. And so to track which numerators we've already seen so that we can detect our repeat, we're going to have an array here called visited, and it's going to have 1,000 elements. Okay. So let's see, we're going to need the numerator and the denominator. We're going to need an index I to keep track of how many steps we've taken, so we can keep track of the length of our cycle. And then I'm going to pull in a utility that we wrote a few videos back. Utilities.h. And let me just pull that up real quick to refresh your memory. So we have this Superlatives template class that's just used for tracking the largest or smallest value associated with some piece of state. And so we're going to use that here. I'll put a link in the description to the video where we wrote that, so if you want to go back and check that out, you can do so. Okay, so we're going to say superlatives, and the state is going to be the denominator, so that's a uint32t, and the value is going to be the length of our cycle, so also a uint32t. And we'll just call that super. Okay, so we want to start by verifying that our code will work for the example that they gave. And so you'll note that this was for denominators less than or equal to 10, and it gave 7 as the correct answer in that case. And so, so let's say const uint32t max denominator is going to be 10 to start with. Okay, so we're going to say for denominator equals 2. Denominator is less than or equal to max denominator plus denominator. Okay. And also, we're going to have to clear this, this visited array for each denominator. And so let me just pull in another useful utility here. This is going to be in string.h. The utility actually has nothing to do with strings. I don't know why they put it in that header file. But that's going to be memset. And so this is just for clearing that block of memory. So we're going to clear our visited array with zeros, and that's just going to be denominator times size of uint32t. Okay, so we've cleared our array. You'll note that we're going to be starting with we can actually start with I equal to any value, because all that matters is the difference between the starting value and the value we end up at. And so it doesn't really matter what we set it to, but we can't set it to 0 because we're using 0 as our cleared or unvisited value. And so we'll just set that equal to 1. That'll be fine. Okay, and so now we're going to say while not visited numerator. Oh yes, we also want to set the numerator here is going to start at 1 because we're starting with the reciprocal. So we're going to say while visited numerator is equal to false. Then we're going to say that the new numerator is going to be, we'll say numerator is equal to numerator times 10 mod denominator. Oh, and before we do that, we actually want to note that we have now visited this value of the numerator. And so we'll say visited numerator equals I. Okay, now we've calculated the new value of the numerator, and we want to increment I, and that should be what we want. Okay, so after we've looped until we repeat some numerator, and then we'll break out of this loop, and then we can determine our the length of our cycle just by looking at the difference between the value of I that we currently have and the value in the visited array. And so we'll say super dot add state, and so the state is going to be the denominator, and as I said, the score is going to be the length of our cycle, and so that's just going to be I minus visited numerator. And then once we're done, we can say printf longest cycle occurs with d equals %u, and then we'll say length equals %u. And so that's just going to be super dot max state and super dot max val. And that should be good. Let me, let's see, go back to the shell here, go into our problem directory, and looks like that builds. And it does indeed say that 1/7 has a cycle length of 6. And so now let's crank it up and see if we get the right answer. You'll notice that the maximum denominator is 999, not 1,000. It specifically says less than 1,000 here. So we'll be sure to do that here. And make and solve. Okay, so this says that the longest cycle has length 982 and occurs when the denominator is 983. So let's go back to the archive here, and we'll see that that is indeed the answer. So that will be all for this video. In the next video, I'm going to take a look at solving this problem with analysis. I think it's going to be a bit tricky, so there's a chance that that may not be the next video that comes out. But in either case, it'll either be another video on this problem or moving on to problem number 27.